Another one of the important parameters which decides the mechanical properties of the materials is grain size, and grain reduction in grain size is a very desirable process which can lead to multiple benefits in the mechanical behavior of materials. Let us see that first. If the grain size is reduced, it leads to increase in strength, that is by using of Hall patch relation. Hall patch relation has a K as a Hall patch constant, and this effect is more pronounced in BCC materials such as iron, which have high Hall patch constant, rather than FCC materials such as aluminum, which have one order of magnitude less than the BCC material. The equivalent reduction in grain size will have one magnitude of higher increase in strength in BCC materials like iron. So this is one of the important parameters, but this relation is applicable only in certain size range, and below the micron size this relation does not hold applicable. Second is the ductility. One of the benefits of the grain refinement, in contrast to other strengthening mechanisms such as salt solution hardening, work hardening, is that it does not lead to decrease in ductility. With the decrease in grain size, we can have material which higher strength at the same time with higher ductility. So that is one of the important points of this particular treatment. Another important point is that ductile to brittle transition. So materials such as BCC iron, which are very prone to brittle behavior at lower temperature as compared to FCC materials, have to be very carefully designed, and decreasing the grain size lowers the ductile to brittle transition and leads to increase in toughness over wide range of temperatures. So that gives us a benefit of utilization of these materials in much wider applications. And lastly, fatigue resistance is also improved by the decrease in grain size. In effect, grain refinement is one of the most desirable strengthening mechanism as compared to the all other presently available strengthening mechanisms. If we look at one of the applications in which grain refinement is very widely beneficial, is the area of micro-rolled or HSLA steels. We know that in HSLA steels we have high strength low alloy steels, we have small amount of strong carbide forming elements such as niobium, vanadium and titanium added at higher temperatures. If they are heated to high temperatures, and such as during hot rolling, so they are soaked before the rolling, so these elements usually get dissolved in the austenite phase, so they are soluble in the austenite phase, and during the hot working, so based on the mechanism of strain induced restoration, so because of the strain which is being absorbed in the material, which is being spin in the material, there is a precipitation of these elements as carbides during hot rolling, and this leads to the pinning down of grain boundaries, so they segregate along grain boundaries and reduce the tendency of the grain growth, and this is very helpful during process such as hot working process or hot rolling, because in this process there is a continuous recrystallization of the grains occurring during the process, and in that case there is a higher probability of grain growth. So in the multiple passes, if there is even recrystallization is happening, they will inhibit the grain growth and lead to a finer grain size in austenite, and that will in turn lead to finer ferrite grain size and better properties in the materials. So these are the ways in which external constituents also help in the grain refinement and finally lead to better properties of the materials.